Thank you, Alex. Great way to kick us off. DCC is really one of the technologies of the future. And we are here today as the next conference from the DePIN conference, Decentralized Physical Infrastructure. And I would like to welcome Dr. Christian Miller to come up and speak. Dr. Miller is actually the head of research at Acurast, which is one of our platinum sponsors today, and I want to hear more about your work with Moore's Law, because that's really interesting. Moore's Law and network effect. But I don't know what you're going to talk about, but here you go.
Thank you so much. It's killer, but don't be afraid. No worries. Miller, Killer, Keller, everything's the same. It's fine. So it's just a Swiss name. It's not dangerous. And I'm not going to talk about Moore's Law, but I can mention it on the side. No problem. So similar to Alessandro today, I'd like to open with open crowdsource. So sort of a combination of open source and crowdsourcing, because I believe we have to go back a little bit, take a few steps back and think about what Chris Dixon wrote, and also our previous speaker said, is that it's about decentralizing verifiable and confidential compute bottom up. Oh, thank you so much. The big one. Hey, it looks encrypted, looks quite military grade. Thanks. So, you might have heard this pitch many times before. It's shunning all these centralized clouds, but it's quite remorseful to say that 66% of the global cloud market is actually in the hands of a few players, so super monopolistic. And we're talking about DCC, which is also what I'm very, very passionate about. And then it comes to data ownership, because we don't own anything of the data, and we have to trust all of these providers to actually run things the way they should be run. And if they shut us down, we cannot do anything, and we don't have any censorship resistance, right? But going further into this HSM hole, if we buy or an offering that says AWS HSM, we cannot verify it end to end, right? So that's one of the key issues that should be addressed. What is Acurast doing differently from a lot of the other players? I'd like to highlight that. We leverage mobile hardware because it's up to 50 times more power efficient, so you pay less power. But also because we have these special purpose chips, which are much more efficient. So you have like more efficiency, and also, depending on the hardware acceleration, even faster chips than traditional server hardware. So these are the two things, but lastly, also we have, depending on the device, so-called co-processors. So looking at Google Titan M2, we have really a separate chip. So not like traditional trusted execution environments where the CPU has a separate encrypted part in the application memory. But with, for example, with mobile phones, you really have a separate chip that is running completely autonomously. So you really operate with a black box there. Looking at some numbers, comparing it to a traditional power edge server. So this is where we have Moore's Law, because the founder of ARM said that performance per watt is the new Moore's Law. And this is why, because we have ARM-based chips inside of these Pixel devices. And as you can see, the acquisition price is 6 times cheaper, but we have the same CPU mark, and also 83 times better performance with machine learning. For example, when we leverage a TPU inside of these phones. And then looking at the energy cost, it's even 50 times. So it's a no-brainer to actually leverage mobile phones to build a decentralized cloud. What's the killer use case? Haha, pun intended. Up to 117 times cheaper if you buy recycled or broken phones. So for instance, if you have just one functioning screen and 3 identical phones, you can just swap the screen, onboard it, and then you're good to go. And as you can see, on secondary market, we really have cheap phones ready and available to use for that. So here we have, of course, the discussion and the elevator pitch of Acurast always ends with the question, but can you really compete with centralized players? Here's the answer: yes, we can. So as you can see, this evaluation doesn't include latency. So this is pure execution time on random devices. So we didn't even prefer a certain type of device because some of them, of course, have better clock rates and are faster. So we just took 100 random devices from the network and then ran the same script, which is prime number generation up to a certain threshold. And then we took the average there. And as you can see, AWS Lambda is slower, Google Cloud Functions are slower, and Azure Functions is barely on the map here. And as you can see, we were faster all around. Up to 117% faster than Microsoft's offering. So this is why we can actually compete against centralized players, even if we include the latency. If we add the latency, we can, the more the network grows, as of now we have 6,500 devices, as more the network grows, you can use edge devices that are as close as possible to your location, right? For example, you can even connect phones through the USB-C port to a gigabit port adapter, and then you have a direct, more or less direct cable connection. So it doesn't necessarily have to be through Wi-Fi. This is an overview of the ecosystem. So we have a different host of demand-side applications. So for example, we have on the Web3 side, we have Web3 oracles. So for example, people are on-demand fetching prices, or they are using it as a Bitcoin MPC solution, so to have an MPC wallet or multi-sig thereof. We also have the option, as our previous speaker also said, to settle on different chains. So for instance, you can say I want to publish a price on Polygon, and then you run this script continuously or on demand, not continuously but repeatedly on a schedule, and then put the price on another chain. This is the Web3 side. But we also have Web2 side because it's general compute. You can compute anything in Node.js, Python, and JavaScript V8. And I dare to say that 80% of the internet's web infrastructure is running inside of JavaScript and Node.js. Of course, we have Python for machine learning, but most of it is JavaScript based. So you can simply take that code and also deploy it to Acurast. And then even since we're talking about DCC, make sure that everything is just running on specific devices and is end-to-end verifiable and even confidential inside of the bootstrapped trusted execution environment. On the supply side, whoopsie, we have people going crazy with farming. So we have a lot of people that provide compute, as you can see all around the globe. And we have, as of today, 10,000 plus on-chain accounts, around 6,500 devices onboarded, and this is growing steadily as well. We also have exciting news to announce today, where we're launching a so-called Processor Lite edition. So as of today, you would have to factory reset your device, only Android-based devices, factory reset it and put our processor software on it. But we're announcing that we have Processor Lite version, which means that you can just run it in the background. So for example, download an application on Android and iOS, and then it will compute within that constrained application instead of having to dedicate your full phone, right? So much more accessible and definitely will grow our supply side even more. Yes, and last but not least, everybody likes a good loyalty program, right? Everybody likes to collect points, and everybody likes to be a rebel. So we have the combination of all three things here in our Cloud Rebellion program, which, please join us to fight the centralized lords of the cloud, and let's make cloud computing. Yes, please. I don't, but maybe so. I think Andreas, our developer experience expert in the back there, he has one, I'm pretty sure. Thank you. Thanks. Thanks for the attention. Thank you, Lisa.